What we're going to look at in this video is we're going to look at how to deal with imbalanced data. And so what we're looking at over here is a dataset with different classes, and we're going specifically to look at a dataset with two classes. The one class having much more observations than the second class. So the second class will be the small class, and the first class will have a large number of observations, and we want to somehow balance the data set, meaning that we want two equal size classes. The packages that we're going to use in this video of dealing with imbalanced data is the host package and the SMOTE family package in R. So install those two packages. The data set that we're going to use is the iris data for illustrative purpose. What we're going to do is we're going to change the iris data set into a two-class data set. So we're going to deal only with two, and then we're going to also make it a imbalanced data set, because we know from previous exercises the iris data is a balanced data set. Then we're going to apply the host package and the SMOTE family package to do different, or to apply different methods of sampling. There's the over and undersampling, oversampling, undersampling separately, and then the host package as the row sampling method, which is a method to generate artificial data sets. So the Addison, the Rose, the SMOTE generates artificial data sets. Okay, so let's look at how we can generate artificial data to balance an imbalanced data set. Again, in RStudio, there's a script file that is available. So again, I have my workspace that I'm going to store data sets that I'm going to create. Remember, in this case, we're creating a balanced data set from an imbalanced data set, so we want to save those data sets maybe as well. So always change the working directory to where you want to save all your data. So this is what the script file looks like, and so let's work with the script file in RStudio. So back in RStudio, open the script file. Okay, so there's our file, and so there's everything that we want to execute. Let's close our console window at the bottom, or clean it, so that everything is clean for us. And the rows in the SMOTE family, those two packages needs to be installed before you can execute these commands. Okay, so let's execute them. Until enter, and now it's loaded. Let's set our working directory. So once you've created your working directory, you can run that, so that everything that we're going to use, I'm going to store or save under this directory. And then over here, the set seed, I'm going to use this. If you reproduce this data set or data sets, then it will all be the same. So the set seed is just to make everything reproducible in this illustration. We're going to use the iris data set, so let's call up the iris data, saying data iris. Okay, so the iris data set is now loaded. The set seed, to make everything reproducible, you will find when we execute these functions for imbalanced data, they will generate new data sets every time you execute them. So set seed will just make it reproducible so that you can generate the same data sets as what I will be generating. So we're going to just quickly create a two-class data set. Notice over here, I'm taking out the Virginica, I'm taking out the versicolor, and then over here, I sample from, I create an index over here using the function sample. Let's quickly execute these two so that you will notice what's been happening. So if you look at the Virginica and the versicolor, those are just the two data sets. Let's look at what the index does over here for us. So index, notice over here, index contains the 10 observations that's randomly generated. So I know there's 50 observations in each of those two data sets. So what I did was I randomly generated 10 observations in my index, and notice what I do over here is I take the Virginica data set using the index, so I take out these 10 observations and I call it VER1. So VER1, if I execute this over here, notice what will happen. It will just be a data set with 10 observations. Okay, so VER1, there's a data set. Okay, those are the observations that I took out, and here's the observations, 10 of them. Okay, and so if I combine the Virginica with the VER1, you will find the following imbalance data set was created. So look at, or let's view IMB data for imbalance data. There's a data set. Okay, created or generated this data set. There's the Virginica. There's the 50 observations, and then the rest is just 10. Okay, so 50 and 10. That's our ratio of the species. We can quickly create a table. So if I say table imbalance species, okay, so notice there's 10 and 50. There's no setosa. Okay, so it's only this data set that we are going to work with. Okay, so imbalance data. Let's make a pairs plot. So we know what pairs does for us. It creates a scatter plot. And so we removing the last column and then call equals as factor. And then what the as factor does, it uses the fifth column, the species column, and it will create the color based on that as factor. Okay, so this is just basically to create different colors using the column of the species. Execute, and there's our plot. Okay, so notice over here the red would be the versicolor, and the green would be the Virginica. Okay, imbalance data, that's what we've created. So small sample and a large sample. And the idea now is to generate data so that these two classes will be the same. Okay, so there's different methods that we will look at. So first we're going to look at the over and under sampling. Now there's this function over and sample. It's in the rows package, and what you do is you give the label of the categorical variable, in this case the species, and we want to use the imbalance data. And what we're going to do is we're going to reduce the data set so that each data set, or so that the data set has a total of 100 observations. Okay, so let's see what this does for us. So this is the number of observations that I want in the end, and the both means it's oversampling and undersampling. And in the end, I want 100 observations. So let's execute this command. And notice over here, oven gives us a list, and we just want the data. So let's quickly run this part so that we can see what oven with the both give to us. And then let's see the list, the output in this list. Okay, so there's the output. Notice over there, there's 100 observations in total, the N total, and here's the Virginica and the versicolor, and suddenly you see there's 50 observations for each group. And so what it did was basically it generated from the red data points, it randomly sampled from those red to generate new data points to make it a balanced data set. Okay, so the next part table, just to show us that the classes are now balanced. So let's execute this whole thing for the B data. So B for both. So there we have the data. We can execute the table command showing us how the function, it balances the data. So remember what it does, it selects randomly from both groups and to balance it, making it equal to 100 the total. Okay, not completely balanced, but balanced enough to have an equal size group data sets. So the pairs, we can make a plot similar to this. So just to illustrate what the new data set looks like, notice over here the red and the black ones are now new data sets generated from the original data set. Okay, that's over and undersampling. Okay, so meaning what it did was it worked on upsampling as well as downsampling. Let's look at the next one using the over method. Okay, so the O data, I execute exactly the same command as what we have over here, but here I say the proportions in the groups must be the same. Okay, so P.1 means 50% in the one group and 50% in the other group. So if we execute over here, so over means it will upsample. Okay, so it will take the small group and make the small group bigger. So let's do this. And let's execute the table. And notice what happens over here. We have a 50-56 proportion. Okay, so it randomly does the proportions for us. But again, we have a situation where we've upsampled. We've made the smaller group bigger. Okay, so let's remember the 50. 50 was the original size, and so the versicolor was the smaller group, and now suddenly it's 56 over here. Okay, notice if we make a plot of the O data, the oversampling, the pairs plot, what it looks like. So there's the pairs plot, the red ones. Notice over here it didn't change the data set distribution that much because we're generating the same data. So lots of data being the same in this case. Okay, so that's oversampling. The next one is undersampling. Again, executing the same commands. 50% approximately in both groups. That's what we want. We want to undersample, meaning we want, remember the original data is 50 in the Virginica group and 10 in the versicolor group. So what we're going to do is we're going to downsample from the large group this time. Okay, so you're not going to upsample like this one over here. We're going to downsample the large group. So let's execute this one over here where we use the under table. Let's see what's happening over there. And notice over here, the Virginica is now reduced to 11. Remember it was 50 and now it's 11. The versicolor was 10 and it's still 10. So this part over here, we downsample the large group. For this one over here, we upsample the smaller group. Okay, and there we applied both. That's why we see both have more or less equal size over there, the 50-50. Okay, so that's the upsample, the downsample, and we can make a scatter plot of this one as well, just a small group. Okay, so up to now we haven't created any new or artificial or synthetic data. We just resample from the original data. Okay, sometimes that's called bootstrapping. So we just bootstrap observations from the same sample or data set. So let's look at the Rose sampling technique. Okay, so again in the literature, you may want to go and read what the Rose package or the Rose method does, but it creates new or synthetic data for us. Okay, so we start with the imbalance data set and we want to generate, in this case, 100 observations, meaning if we want to balance it, there must be 15 the one, 15 the other one, approximately. Okay, so for the rows, we do exactly or similar over here, but instead of using the oven sample function, we use the rows function. Okay, so let's execute this one over here and see what the rows function will give us. So we call it the rows data, and so rows data, let's table the species column. So we want to see what that looks like. So we see over there 43 and 56. Okay, and now we can view. Let's first view the rows data. Okay, and if you view the rows data, notice over here it's completely synthetic. Okay, so all the numbers, all the observations that you see over here, everything has changed, and so the algorithm, the Rose algorithm, has generated completely new data for us. Okay, and let's plot the data. So for the rows, let's use a pairs plot, and there's the data set now. Okay, so it looks and behaves like the original iris data set, but we've created a completely new synthetic data set. Okay, so that's something that often is being done in statistics and has quite useful applications. The reason why we want to balance a data set in classification, often the classification algorithm works better if the data set is balanced. Okay, but in the real world, often what happens, there's an imbalance problems or data sets that gives rise to imbalance data, and for example, there might be lots of data of healthy patients, but only few data points of sick patients. And if you want to classify a patient as sick or healthy, then the imbalance would have a negative effect on the classifier. So for classification specifically, imbalance could be something that affects the classifier. So you want to balance your data set in that case. Edison is another example. Again, Edison is an acronym for how the data is generated. Edison, let's quickly look at this function over here, addis. If you look at this function, addis means it's part of the SMOTE family package. It's adaptive synthetic sampling approach for imbalance learning. And exactly how it works, you can study this paper over here. And basically, it's going to create a similar data set as what we've seen with the ROSE package over here. Also another synthetic data set. So you give the data, and then over here, notice what I did. I specify the column for the species. So that's our grouping variable or our classes. And then k equal to 5, using the k 5 nearest neighbors in this case. So Edison and SMOTE later uses this k to generate or to use as a way to obtain the additional or the synthetic data. So let's run the Edison over here. Let's take note of what the classes looks like now. So notice over there classes have been balanced, and now we can make a plot of the data generated by Edison. And notice over here this data set maybe not looking as good because it didn't it doesn't look as the spread doesn't look as good as the original data or as what we obtained with the ROSE function. Okay, so that's the Edison approach. We can change the 5. We can make this, let's make it 10 and see what's happening if we make it 10. So let's make it 3 and see what happens if we make it smaller. Okay, so small changes happens to the data set. And then the last one over here is the SMOTE data set. So the SMOTE data, again, we would want to maybe look at SMOTE, the SMOTE package or the SMOTE function. And it's the synthetic minority oversampling technique. So it's generate synthetic positive instances using the SMOTE algorithm, and again the k, the number of nearest neighbors during the sampling process. These methods, it's important to study what they do, how they generate the data, and in the end, if you apply these methods, you would probably want to apply a few just to see which one gives you the better better results if you want to generate synthetic data in a classification setup. Okay, so ROSE, Edison, SMOTE, and there's some more methods available. Which one works the best probably depends on your data set and also how the classifier performs on each of them. Okay, so the SMOTE, let's execute the SMOTE, the final one, and then there we see the SMOTE. Okay, so up to now what we've seen, the pictures was just there to show you how the new data or the new data for the two groups looks like. But if I just look at the pictures, I would say that the rows that we had over here, if I run this again, the rows gives me a much better spread of the data, and we could compare this to the original data and see what that looks like. Okay, so for the original data, let's see if we can make a plot for the original data. So let's take this command. Just going to put it over there, and it's the iris data. And then over here, we're just going to use the iris, the last column. So that's all that we need to change, and this is all on the original data. And before we continue, we are going to use the Virginica and the versicolors. I'm just going to use observation 1 to 100, observation 1 to 100, because I know the first 50 is the Virginica, and then the second 50 is the versicolor. Okay, so that was just an important thing to use. So execute, and there's the data. Okay, so let's do this again. I just want to quickly do this. Okay, let's have a quick look at the iris data. Oh, sorry, it's the versicolor 51. Okay, so my mistake. So it's 51 up to 150, and 51 up to 150. Okay, so there's the data set from this. Okay, let's plot the original. There's the original. Look at the spread of the red ones and look at the spread of the green ones. So the red ones are quite spread out if you look at all of them. So I would expect the synthetic sample generated to be similar. And like I said, if you look at the rose one over here, the rose picture to me looks much more spread out. So I would say the rose and the original data, they tend to look similar for me. Okay, but in the end, what we would like to do is we want to save all these things. So notice over here the right, the table, the U data, the O data, the B data, so the undersampling, oversampling, both under and oversampling, the rose data, the Addison data, the smoke data. We could save that by writing it to the folder, and that's the folder where we have that we set the working directory to before. And so executing this over here, Control Enter, we will see that all those files have been saved for us. Okay, so now we can use this for other applications. Okay, so always useful to save new data set or any analysis that you've run in R. So finally, again, what I would like to do is introduce a little bit of R Markdown. Okay, so R Markdown is a wonderful tool to use as well. And what we're going to do is we're going to generate a document or a report in R Markdown with what we've done. Okay, so normally what you do, sometimes you have an assignment that you need to do and you want to execute your commands and you want to display your graphs and tables, and you can do that using R Markdown. So R Markdown being used for report writing. Okay, so let's go to R Markdown or create the R Markdown file. So click over here, there's the R Markdown. We can give it a title, so we can call it Imbalance Methods in R. That's our title. Again, maybe we want to create a Word document, or maybe after this we can experiment with the HTML. So let's create a Word document and see what it will look like. So if I say OK, then again R will generate this document for us. Notice there's some information over here that we're not going to use at this stage, but as we learn our Markdown, we will find there's lots of things that we can do when we make our documents. So at the moment, I'm just going to remove this part over here so that we're left with these over here. And again, this part is what we call the YAML. Okay, and then we can write some text over here. So we can write this is my class imbalance assignment, and you can type out a whole paragraph over here and so on. The more you learn about R Markdown, you can include chapters, you can include headings, subheadings, and so on, tables. You can make the report beautiful and so on in R Markdown. But for now, important is you need this YAML for formatting the report, and we're going to write it to a Word document, but you can write it to HTML as well. You can write text to explain what you did, and then if you want to insert the R chunk, you can just click over here. Notice you can, if you click on this button, it says insert new code chunk, or you can use the shortcut by typing Ctrl-Alt-I. So click there. What will happen is you get these options. So we use R. You can use other chunks as well. So notice over there you can use Python and other packages and execute the R. You can knit the R Markdown file from here for all those packages, but we use R, so we're not interested in those over there. But what we can do is over here is where we would normally write our R code. So I'm just going to copy everything that we did over here. So copy that and then paste it over here. Okay. So now our code, and if we want to write text, more text, we can type it in over there. And if we run this by clicking the knit button over here, it will create the R Markdown or the Word file from this R Markdown code over here. So this is the R chunk, that's the text, and the top part is the YAML. So those three components is what you would use to generate the following. So if you click knit, and then we have to save it. So we're going to save it over here. So I'm just going to say the imbalanced R Markdown file. Okay, so that's the text file, and now it's going to render. In other words, it's creating this Word document for me, and notice it will save the Word document in this directory that we created over here. So this directory is where we saved the R Markdown file, and so the Word document that's been created over here will be saved in the same folder. And there's the result. Here's the imbalance text file that we created in R Markdown, and there's the file. Okay, so notice there's everything that we've executed. There's the graphs, even the comments is there, everything, the text that we created right in the beginning. You will see there's the text, and you can type more. For interest's sake, if you want to change, notice over here, you can, if you go to chunk options, not that, if you go to the output, sorry, you can select what you want or not want. So it must show the output only, the code and the output. It must show nothing. Let's say you choose this one over here, show nothing, don't run code. It won't do anything for you. over here it will run the code, but it doesn't show the output. Here it will show the code as well as the output. So let's say you only want to generate the output. Okay, so notice what happened over here. Echo equals false is now introduced. So what echo equal false will do, it will only display the output and not the code. So let's run this. We'll knit this, as I would call it over here. Notice over here it's only the output and there's no code over there. Okay, so all the graphs that we created, but there's no code included in this document. Okay, so sometimes you want to give the code, sometimes only the output, and you can put the settings over here depending on what you want. Normally for an assignment, if you do an assignment, you would want to give the code as well as the output to your lecturer. So echo must be equal to true. The default is true. If you do a project, for example, you don't want to give the code, you only want to generate the graphs and then create a discussion around the graphs in Word, then you can keep that. Okay, but you can play around with the options over here. Okay, you can even create at the end, you can create more R chunks. So let's say you have some more text over here to write, and then if you again click over here and you click there, it will create another piece of R chunk and you can run more R code. So you can write as many pieces of R code and text, and that's how you would write the project. Okay, so you would write the discussion, give your R code, and then run the R code, give a discussion, run your R code. So you can run multiple sets of R chunks and write multiple sets of text within the R markdown over here. Okay, so R markdown, and let's quickly just see what, I'm just going to delete this. Let's quickly see what happens if I knit it to a HTML, for example. So let's knit it to HTML. So it will give you this over here. So it's maybe nicer to view where we saved it. So notice there's the Word file that we created, and there's the HTML. So if I open the HTML, it will look something like this. And the HTML file you can, for example, publish to a website. Okay, so there's the same output that we saw earlier in Word, but this time just knitted to a HTML. Okay, so HTML, Word, and so on, you can use all of that and you can create your report. For example, let's say this was your report and you needed to discuss something and publish it to the internet, then your text would be over there, your discussion, and everything else would be the output that you generated. Okay, so that's a little bit of R Markdown and how we would work with it. But there's much more that we can do with R Markdown. R Markdown being a powerful tool for report writing. Thanks for your time.